Hi students, today we will discuss about rational numbers and irrational numbers. Rational number. The numbers which are in the form of P by Q, where P and Q are integers and Q not equal to 0. What is P by Q form? All of you know about fractions. Suppose I will take 3 by 4. Here 3 is numerator and 4 is denominator. And here P is numerator and Q is denominator. So a number which is in the form of P by Q, then this number is known as rational number. But here Q not equal to 0. Why? Because if Q is equal to 0, then this value is indefinite. So Q is always a positive number. Next, irrational number. A real number is called an irrational number if it cannot be the form of P by Q. Cannot be form of P by Q. Where here P and Q are integers and Q not equal to 0. If we take root 2, what is the value of root 2? 1.414. And this value is continuing. So this is the after decimal points, this is not terminating. So such numbers are known as irrational numbers. Root 2, for example, root 2, root 3, root 5, like that. These numbers are all irrational numbers. Expansion. What is a decimal expansion? Suppose if you take the value of 0.375, then we will write it as 0.375 as 375 by 1000. So 375 by 1000. That means I will write it as 375 by 10 cube. And one more thing, 12.5. I will write it as 125 by 10. Why? Because we write here after decimal point we have 3 numbers. Then that's why we have write 3 zeros. Here also after decimal point we have 1 digit. Then we will write 1 0 like that. Now I will explain some examples. Now I will discuss about terminating and non-terminating decimals. I will take the fraction of 3 by 8. So we will divide 3 with 8. So 8. 3 is less than 8. That's why we put point here and put 0 here. 3 8s are 24. 6 again put 0. 8 7s are 56. 4 0. 8 5s are 40. So here the remainder is 0. The decimal value of 3 by 8 is 0.375. After that here no value is there. So this is known as terminating decimal. Suppose I will take 1 by 3. I will take 1 by 3. If we divide 1 with 3, here 1 is less than 3. So that's why I put point here, put 0 here, and 3 3s are 9. And the remainder is 1. Again I put 0 and 3 3s are 9 and 1. So this is repeating. 3 3 3 3 repeating. These have no ending. So we will write it as 0.333 and so on. So this is non-terminating decimal number. I will write like this, 0.3 bar. Why I put bar here? That means this. Now I will tell you one theorem. Let x be the rational number whose decimal terminates then x can be expressed in the form of p by q. Two are co-primes. And the prime factorization of q is of the form 2 power n into 5 power m, where n and m are non-negative integers. Now we will see the examples of this theorem. I will take the value of 8 by 125. No, I will write 8 by 125 means 5 cube. And here only 5 power m value is there, but 2 power n value is not there. That's why we will multiply both numerator and denominator with 2 cube. Then we will get 8 into 8 by 5 cube into 2 cube. That means 10 cube. That equal to 64 by 1000. So that equal to 0.064. So if the denominator is writing like this, then this particular number is a rational number. I will take an example. 3 by 8. I will take 3 by 8. Here 3 by 8 is rational number, and we will write the decimal form of this rational number, and this is terminating or repeating decimal or not. We will check. Now 3 by 8 means 3 divides 8. If we divide 3 with 8, then we will get, suppose here 8 is less than 3. Sorry, 3 is less than 8. Then we will, here we will put point, and here we will put 0. Then 8 6s are, 8 4s are, 8 3s are 24, 6, and again we will put 0. 8 7s are 56, remaining 4, and again we will put 0. Then 8 5s are 40. Here remainder is 0. So when remainder is 0, then that rational number is terminating number. So now we have 3 by 8 is equal to 0.375. I write the decimal form of this 3 by 8. And this is terminating or not? When remainder is 0, then this decimal number is terminating decimal number. So 3 by 8 is terminating number. And one more example, 229 by 400. Now I will write 229 divides 400. I put 0 because 229 is less than 400. That's why I put point and 0. So 4 times 2000. Then we will get 290. Next 7 times. I put 0 again. 2800. Then 100. And again I put 0. 2 times 800. So 200. Again I put 0. 5 times 2000. 0. Here remainder is 0. That's why the decimal form of this rational number is 0.5725, and this is terminating decimal because remainder is 0. If any denominator is written like this, like 2 power n into 5 power m, written like this, then this fraction is known as a rational number. Take one more example. 13 by, now I will take another example, 13 by 25. So 13 by 25 I will write as 13 by 5 square. Here also 2 is not there though, that's why we multiplied with both numerator and denominator with 2 square. Then we will get 13 into 4 by 10 square, that equal to 52 by 100, that is equal to 0.52. I will explain about irrational numbers. already told irrational number is not on the form of P by Q. So irrational number is not of the form of P by Q. So what are irrational numbers? Root 2, root 3, pi. Pi is also an irrational number. So on. And I will explain one theorem about irrational number. If P divides A square, then P divides A. If P divides A square, then P divides A. When P be the prime number. If P divides A square, then P divides A. When P divides a prime number. When P be the prime number. Now I will take proof. Let the prime factorization of A is, I will take A equal to P1, P2, P3 and so on up to Pn, where P1, P2, P3 are prime numbers. Then squaring on both sides. What we get? A square equal to P1 square, P2 square, P3 square and so on up to Pn square. So therefore A square, so therefore P divides A square. We know that fundamental theorem of P, a fundamental theorem, P is one of the prime factor of A square. P is one of the prime factor of A square. So by using uniqueness of the fundamental theorem, only prime factors of A square are P1, P2 and so on up to Pn. So A is equal to P1, P2, P3 and so on Pn. Here P divides A. Now I will tell one example, show that root 2 is irrational. First let us assume root 2 is rational. That means we know that P rational form as P by Q. Then root 2 is rational. That's why P by Q equal to root 2. So now here P and Q are common factors. So multiply, cross multiply. Then P equal to root 2Q. So squaring on both sides. Now squaring on both sides. Then P square equal to root 2Q whole square. That means 2Q square. That means P square is equal to 2Q square. Already we know the theorem. If P divides A square, then P divides A. On basis of that theorem, here 2 divides P square. Then it also divides A. It also divides P. So then we write it as P equal to now for some P equal to, I will write 2C. for some integer c. So substitute the value of p in this equation 1. Substitute the value of p in this equation 1. Then we will get 2c square equal to 2q square. So that means 4c square equal to 2q square. So that implies 2c square equal to q square. So that means again here 2 divides q square and 2 divides c also. So therefore both p and q are common factors, but in it contradicts the fact. So root 2 is not a rational number. That's why root 2 is an irrational number. Now I will explain about one more example. 6 plus root 2. 6 plus root 2 is a rational or irrational. We will prove this. Now we will take 6 plus root 2 is rational number. So 6 plus root 2 equal to rational number. That's why we will take a by b. So now root 2 equal to a by b minus 6. I will transpose this 6 to that side. Then we will take squaring on both sides. So root 2 whole square equal to a by b minus 6 whole square. Then we will get 2 equal to a minus b whole square. A square plus b square minus 2ab. We will get so that equal to a square by b square minus 12a by b plus 36. So that equal to a square by b square minus 12a by b. I will take this 36 to this side. Then we will get a square by b square minus 12a by b equal to 34. Now I will write this equation as 12a by b minus a square by b square equal to 34. I will multiply both these sides. So this is not a rational number. This is not a rational number. So 6 plus root 2. We assume that 6 plus root 2 is rational, but this is not a rational number.